Hi everybody, my name is Camille and I am one of the core developers of the Universa project. And today, I would like to bring you in on some details about what the Universa project is about, what are we building, and what are the plans for the future, as we attempt to build intelligent agents communicating within a network. In order to understand how we got the idea for this, we need to take a step back and see what was the historical beginning of the whole Universa project. So in the beginning, I'm going to talk a little bit about how we initially wanted to empower agents with complex abilities without even thinking about any form of communication or a framework. Then we're going to take a look at what we've built already, and I'm going to show you a few code snippets of what kind of tools we have implemented. And then we're going to talk about what we're focusing on right now, which is building tools for the agents to communicate with each other within a network. And at the end, we're going to take a look at the big plans and the vision that we have for the project for the upcoming months and years. And hopefully, maybe you're going to find there's something that interests you and make you want to contribute to this project. So let's get right into it. 1 year ago, when we started the project, we initially focused on empowering AI agents with complex abilities. Now, what are these complex abilities, you might ask? Well, we can understand them as an advanced abilities that constitute, in one way or the other, they constitute an intelligence. Now, intelligence is a very broad term, but if we take a closer look, we can discern certain specific disciplines or specific abilities that we may find in intelligent organisms, or we may find essential for intelligent behavior. Now, obviously this list is much longer than what we have here on the slide, but I think it's going to give you a good glimpse about what we were trying to attempt to do in the beginning. So we're looking at different categories of these complex abilities, human abilities, intelligent abilities, and trying to implement tools for AI agents to be able to use them, to be able to, well, yes, possess them in some way or the other. So abstract and conceptual thinking, it's a pretty natural thing when you think about complex problem solving, right? It's a way to think outside of the box. It's a way to innovate. It's a way to figure out heuristics, how to get from point A to B within a problem space in an unconventional manner. Empathy and communications are capabilities that are so powerful in building groups, teams, societies, and building meaningful and impactful relationships and cooperating together to achieve a common goal. Multimodal comprehension is something that absolutely comes as natural to us as humans, but it's actually not trivial at all, because in order to understand and process so many different types of stimuli coming from the environment, we need to put a lot of work into the machine for it to be able to handle it, while our brain absolutely does it out of the box. Now, last but not least, we've put a lot of effort to think about how to build in this ethical compass into the AI agent. Because when we think about complex abilities and how powerful intelligent minds are, we also find very often that intelligent minds can do a lot of bad things to the world and the environment. And it's important to remember that the AI that we're building, we need to focus, we need to put effort into aligning it in a way that it does not do harm to the society and to the environment that it will be deployed in. So this gives you, I hope it gives you a good example of what kind of complex abilities we're trying to tackle 1 year ago when we started the project. But we soon came to a realization that, we can build complex abilities as toolkits that will be used by agents. But what we actually want to do, much more than that, is to build some sort of a framework, a scaffolding, a foundation for people to be able to build these complex ability tools and agents themselves. Now that brings us to the idea of the agentic framework I mentioned in the beginning, which is the core of Universa. Now, our initial core principles when building this were to make it lightweight and to make it as general as possible, so people could use it to different problems, different type of approaches to problem solving. And obviously this is a big challenge, and by no means we are done with it. But what we've managed to build so far is circling around the idea of a graph. And the graph-based approach is something that kind of came through quite a bit of research, but also from some, let's say, mind experiments. Now, when I personally think about solving a complex challenge, I usually find myself splitting the challenge into smaller tasks that I can figure out on their own independently, or having a knowledge from any other previous task, and then use the completed subtasks to synthesize them in order to complete the big complex problem that I was given. Now it seems a bit, similar to what we can do when we imagine a problem being split into smaller problems and put into a graph, which represent connections between the parent problem and its child problems. And actually, when we thought about that, we figured out that we can use this idea, this notion, in order to allow our agents to solve more complex problems. Now that's where the idea of the state machine came from. We are heavily inspired by previous works, and in the idea of graph of thoughts, you have problems represented as thoughts, and these thoughts are building a graph on which a sort of a state machine, which checks the content of each node it's on and decides what to do next, moves around the graph and decides whether the problem should be split into smaller subproblems or can be solved in some way or refined. And this idea was exactly what we aimed to develop and implement in our framework. Next to that, we also worked a lot to implement specific API provider connections and also an ability to load your model locally. It was very important to give as much tools as we could to connect to your favorite provider or load your locally quantized models. The framework obviously was written fully in Python. Now, I would like to take you through a few examples of the code, starting off with the state machine that I mentioned in the beginning. In this code, you can see how we're creating a simple graph that's just going to be an empty graph, and we're adding a node in form of a thought into it. As I mentioned, the thoughts are problems, and any thought in the graph is either the big problem that we're giving or some form of refined or splitted version of this problem. Now, after we add the node, we can simply create the state machine and run it on this graph. The state machine will start with the single thought that we added at the beginning, and then we'll decide whether we need to split it into smaller tasks or we can try solve it right straight off the bat. As I mentioned, we worked to add different types of API providers than just OpenAI. And here you can see how you can use an output router, FireLava, to add it to your image to text agent and asking questions about an image. Another thing we wanted to add and were able to implement was to load your language model via the Llama C++ library, which allows you to load these quantized versions of models that can fit on devices that do not have access to heavy GPU that these models usually need. And you can use it as the model for your base agent and interact with it just as you would with API provider. But building a framework is mostly focused on the developer. The question is, how do we make it so that we can also invite and engage users that do not have the developer capability. Now, this is where our current work comes in which we're focusing on building a demo of an interface that will allow you to deploy an agent and also communicate with them. And this agent will be connected with other agents in the network, which will be represented visually as a graph in this interface. And this is where the idea of the agent network comes in. That's very pivotal to the whole Universa framework. Now, imagine instead of running a state machine locally on your computer, that you can deploy agents in the network and potentially create a large network with agents of other people in the network and give your tasks, your complex challenges to this network to find a way to solve them. Find the best agents, the ones that specialize in specific prompts, the ones that can handle images or sound, and bring you back the answer. This is the idea of an AI node that we started entertaining recently. And this idea is simply how we can deploy agents within containers and equip them with means of communication that they can interact with each other, with other AI nodes in the network. Now, currently, we build our toolkit strictly basing it on the master-slave paradigm, in which single AI node is the master, and it can then relay information in the network to other slave nodes that were deployed and use them as these helper agents, basically use them as its tools to try to figure out a solution to a problem. But this brings us to the idea of what if we make it decentralized? What if we remove the master and slave and build some way to encourage agents to communicate with each other in order to achieve their own inner goals? This brings us to the future and the ideas that we really want to research and develop. Now, first and foremost, this whole project is open source. So whatever we build and stabilize in version will be released so that people could enjoy it and contribute. I'm really looking for people who want to build this vision together. The idea of the universal protocol of communication is exactly that what I mentioned just a minute ago. If we're able to figure out a way for agents in the network to have their own agenda and be able to communicate their needs with other agents, this might put us on a path to research something that we call a potential emergent capability. Now, emergence, I think the simplest example you can think of it is when you think about your own brain. Now, the brain is just an organic tissue. Well, it's a very complex organic tissue. But at the end of the day, we can put it in a glass and look at it, and without the source, resources and electricity and food for it, it will just be this tissue. But the moment it is activated and all the neurons start firing, I can now speak all these things to you, and you can listen to me and you can think about it. Now, this is what we can call an emergent capability, that parts of the system, if we just sum their input to the system, it's smaller than when you actually look at the system in a whole. And if we are able to provide a way for agents to communicate without any master relaying the information or a user constantly querying the specific agent to do something, then we might be able to research if there is anything happening when you create such an environment and give all these agents ability to develop themselves and improve. Now, this is one part of the roadmap that we see. The other part is actually building a way for the users to seamlessly experience this, one may say, magical world of agents interacting with each other in the network. Just as I've showed you a minute ago, how we're trying to visualize the network, this is what kind of an experience we want to provide for people to be able not just to chat with an agent, but also see what they're talking about, what's happening in the network, and utilize its capabilities. This and many other things build up to our vision of building a decentralized network of agents that communicate, that develop, improve, and refine, and build, amass amazing knowledge base that we can then use to tackle big problems in the world. Now, if there anything that I've just said, if anything of this roadmap or anything that I said before sounds interesting to you, feel free to reach out to us. Feel free to ask us questions, and well, hopefully we're gonna build this together. Thank you so much for your time. Have a great day.